Hi everyone, welcome back to the Comptia Security Plus course. Backup generators. What if the power to the building does fail completely? Most would consider this a disaster, and over the long term it could possibly be. However, most power outages are 5 minutes or less on the average, and most of the time a UPS can pick up the slack for these short outages, but not for the less common longer outages that might last a few hours or days. And a UPS powers only the devices you plug into it. If your organization is to keep functioning, it will need a backup generator to power lights, computers, phones, and security systems over short-term outages and longer ones. A backup generator is part of an emergency power system used when there is an outage of a regular electric grid power. Some emergency power systems might include special lighting and fuel cells, whereas larger, more commercial backup generators can power portions of a building or an entire building as long as fuel is available. For our scenario, we should make sure that the backup power generators, that the generator powers the server room at the very least. Backup generator fuel types include gasoline, diesel, natural gas, propane, and solar. Smaller backup generators often use gasoline, but these are not adequate for most companies. Instead, many organizations use a larger natural gas generator. Some of these generators need to be started manually, but the majority of them are known as standby generators. These are systems that turn on automatically within seconds of a power outage. Transfer switches sense any power loss and instruct the generator to start. Standby generators may be required by code for certain types of buildings with standby lighting or buildings with elevators, fire suppression systems, and life support equipment. You should always check company policy and your municipal guidelines before planning and implementing a backup generator system. Backup generators can be broken into three types: portable gas engine generator, the least expensive and run on gasoline or possibly solar power. They are noisy, high maintenance, and must be started manually and usually require extension cords. They are a carbon monoxide risk and are only adequate for small operations in mobile scenarios. Gas-powered generators are quieter, but often come with a higher price tag per watt generated. Permanently installed generator, much more expensive with a complex installation. These are almost always run on either natural gas or propane. They are quieter and can be connected directly to an organization's electrical panel. Usually these are standby generators and as such require little user interaction. Battery inverter generator. These are based on lead acid batteries, are quiet and require little user interaction aside from an uncommon restart and change of batteries. They are well matched to environments that require a low amount of wattage or are the victims of short power outages only. Battery inverter systems can be stored indoors, but because the batteries can release fumes, the area they are stored in should be well ventilated, such as an air-conditioned server room. With external exhaust, uninterrupted power supplies fall into the battery inverter generator category. Some of the conditions you should take into account when selecting a backup generator include the following. Price. As with any organizational purchase, this will have to be budgeted. How unit is started. Does it start automatically? Most organizations require this. Uptime. How many hours will the generator stay on before needing to be refueled? This goes hand in hand with the next bullet, power output. How many watts does the system offer before purchasing a backup generator? You should measure the total maximum load your organization might use by running all computers, servers, lights, and other devices simultaneously and measure this at the main electrical panel. Alternatively, you could measure the total on paper by adding the estimated power requirements of all your devices together. Fuel source, does it run on natural gas, gasoline, and so on? Is it an automatically starting system? The options will probably be limited to natural gas and propane. Some vendors that offer backup generators include Generac, Gillette, and Kohler. These devices should be monitored periodically. Most companies attempt to obtain a service contract from you, which might be wise depending on the size of your organization. Remember that your mission-critical devices, such as servers, should constantly be drawing power from a lined conditioning device. Then, if there is a power outage to the server, a UPS should kick in. In some cases, the UPS also acts as the line conditioning device. Finally, if necessary, a backup generator will come online and feed all your critical devices with power. Redundant data. Now that we have power taken care of, we can move on to the heart of the matter. Data. Data can fail due to file corruption and malicious intent, among other things. Power failures, hard drive failure, and user error can all lead to data failure. As always, it's the data that we are most interested in securing, so it stands to reason that the data should be redundant as well. But which data? There is so much of it. Well, generally, file servers should have redundant data sets of some sort. If an organization has the building, next on the list would be databases and then web and file servers. However, in some instances, these additional servers might be better off with failover systems as opposed to redundant data arrays, and certainly the majority of client computers, data does not constitute a reason for RAID. So we concentrate on file servers in our original scenario in the beginning of this chapter. The best way to protect file servers data is to use some type of redundant array of disks. This is referred to as RAID, an acronym for Redundant Array of Independent Disks or Inexpensive Disks. RAID technologies are designed to either increase the speed of reading and writing data or to create one of several types of fault-tolerant volumes, or to do both. From a security viewpoint, we are most interested in the availability of data, fault tolerance, the capability to withstand failure of our disks. A RAID array can be internal or external to a computer. Historically, RAID arrays were configured on SCSI chains, but nowadays you also find SATA, eSATA, and fiber channel. Either way, the idea is that data is being stored on multiple disks that work with each other. The number of disks and the way they work together is dependent on the level of RAID. For the exam, you need to know several levels of RAID, including RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10, also known as RAID 1 plus 0. Table 16.1 describes each of these. Note that RAID 0 is the only one listed that is not fault tolerant. So from a security perspective, it is not a viable option. Nevertheless, you should know it for the exam. Okay, RAID 0 striping. Data is striped across multiple disks to increase performance. Fault tolerant, no number of disks. 2. RAID 1 mirroring. Data is copied to two identical disks. If one disk fails, the other continues to operate. See figure 16.1 for an illustration. This RAID version allows for the least amount of downtime because there is a complete copy of the data already at a moment's notice. When each disk is connected to a separate controller, This is known as disk duplicating. Fault tolerant, yes. 2 and 2 only. RAID 5 striping with parity. Data is striped across multiple disks. Fault tolerant parity data is also written to each disk. If one disk fails, the array can reconstruct the data from the parity information. See figure 16.2 for an illustration. Fault tolerant, yes. Number of disks, 3. RAID 6 striping with double parity. Data is striped across multiple disks as it is in RAID 5, but there are 2 stripes of parity information. This usually requires another disk in the array. This system can operate even with 2 failed drives and is more adequate for time-critical systems. Fault tolerant, yes. Minimum number of disks for RAID 0 plus 1 combines the advantages of RAID 0 and RAID 1, requires a minimum of 4 disks. This system contains 2 RAID 0 striped sets. Those 2 sets are mirrored. Fault tolerant, yes. Minimum number of disks, 4. RAID 10 combines advantages of RAID 1 and RAID 0. Normally requires a minimum of 4 disks. This system contains at least 2 RAID 1 mirrors that are then striped. Fault tolerant, yes. Number minimum of disks, 4. Figure 16.1 shows an illustration of RAID. You can see that the data is written to both disks and that both disks collectively are known as M drive or M volume. Figure 16.2 displays an illustration of RAID 5. In a RAID 5 array, blocks of data are distributed to the disks. A1 and A2 are a block, B1 and B2 are a block, and so on. And parity information is written to each block of data. This is written to each disk in an alternating fashion, AP, BP, and as such, so that the parity is also distributed. If one disk fails, the parity information from the other disks will reconstruct the data. It is important to make the distinction between fault tolerance and backup. Fault tolerance means that the hard drives can continue to function with little or no downtime, even if there is a problem with one of the drives. Backup means that we are taking the data and copying it and possibly compressing it to another location for archival in the event of a disaster. An example of a disaster would be if 2 drives in a RAID 5 array were to fail. If an organization is worried that this disaster could happen, it should consider RAID 6 or RAID 10. Windows servers support RAID 0, 1, and 5, and possibly 6, depending on the version within the operating system. But most client operating systems cannot support RAID 1, 5, and 6. However, they can support hardware controllers that can create these arrays. Some motherboards have built-in RAID functionality as well. Hardware is always better way to go when it comes to RAID. Having a separate interface that controls the RAID configuration and handling is far superior to trying to control it with software within an operating system. The hardware could be an adapter card installed inside the computer or an external box that connects to the computer or even to the network. When it comes to RAID in a network storage scenario, you are now dealing with network attached storage NAS. These NAS points can be combined to form a storage area network, SAN. But any type of network attached storage will cost money to an organization. You must classify RAID in 3 different types. 3 classifications can help when you plan which type of RAID system to implement. Failure-resistant disk systems. Protect against data loss due to disk failure. An example of this would be RAID 1 mirroring. Fault-tolerant disk systems protect against data loss due to any single component failure. An example of this would be RAID 1 mirroring and duplexing. Disaster-tolerant disk systems protect data by the creation of two independent zones, each of which provides access to stored data. An example of this would be RAID 0+1. As we mentioned, whatever you implement, the data must be accessible and in many cases highly available. The properly planned RAID system will have high availability, HA, and will be scalable. For example, a RAID 6 system that allows you to dynamically add hot swappable disks and space to add them. You want the system to be elastic as well. Some RAID systems have better elasticity than others, meaning the availability to adapt to workload changes. You might even consider moving certain data away from internal RAID and onto the cloud for additional elasticity. Of course, no matter how well you protect the data from failure, users still need to access the data, and to do so might require some additional networking. Redundant networking. Network connections can fail as well, and we all know how users need to have the network up and running, or there will be heck to pay. The security of an organization can be compromised if the networking connections fail. Some type of connections you should consider include the following: server network adapter connections, main connections to switches and routers, the internet connection. So basically, when I speak of redundant networking, I'm referring to any network connection of great importance that could fail. Generally, these connections will be located in the server room. Redundant network adapters are commonly used to decrease or eliminate server downtime in the case that one network adapter fails. However, you must consider how they will be set up optimally. The second network adapter will take over immediately when the first one fails, but how will this be determined? There are applications that can control multiple network adapters, or the switch that they connect to can control where data is directed in the case of a failure. Also, multiple network adapters can be part of an individual collective interface. When you decide will be dictated by company policy, budgeting, and previously installed equipment. As a rule of thumb, you should use like network adapters when implementing redundancy. Check the model and the version of the particular model to be exact. When installing multiple network adapters to a server, that computer then becomes known as a multi-homed machine. It is important to consider how multiple adapters and their operating systems will behave normally. And during a failure, Microsoft has some notes about this. I left a link in the View Recommend Resources online document. This accompanies this book. In some cases, you will install multiple physical network adapters, and in others, you might opt for a single network card that has multiple ports, such as multi-Ethernet port Intel network adapter. This is often a cheaper solution than installing multiple cards, but provides a single point of failure in the form of one adapter card and one adapter card slot. In our original scenario, we had domain controllers, database servers, web servers, and file servers. These would all do well with the addition of redundant network adapters. Companies should always have at least one backup switch sitting on the shelf. If the company has only one switch, it is a desperate single point of failure. If a company has multiple switches stacked in a star bus fashion, the whole stack can be a single point of failure unless special backup ports are used, only available on certain switches. These special ports are often fiber optic based and are designed either for high-speed connections between switches or for redundancy. This concept should be employed at the master switch in a hierarchical star as well to avoid a complete network collapse. However, the hierarchical star is more secure than a star bus configuration when it comes to network failure. In a hierarchical star, certain areas of the network still function even if one switch fails. This is a form of redundant topology. Finally, your ISP is susceptible to failure as well. As I'm sure you're well aware, most organizations rely on just one internet connection for their entire network. This is another example of a single point of failure. Consider secondary connections to your ISP, such as redundant fiber optics, forming what is known as a redundant ISP, or if you have a T1 line, perhaps a BRI connection will do, or if you have a T3, perhaps a PRI connection would be best. At the very best, a set of dial-up connections can be used for redundancy. Some companies install completely fault-tolerant dual internet connections, the second of which comes online immediately following a failure. If you use a web host for your website and/or email, consider a mirror site or one or more than one. Basically, in a nutshell, it's all about not being caught with your pants down. If an organization is without its internet connection for more than a day or hours in some cases, you know it'll be the network admin and the security admin who will be first on the chopping block, most likely followed by the ISP. Redundant servers. Let's take it to the next level and discuss redundant servers. When redundant network adapters and disks are not enough, you might decide to cluster multiple servers together that act as a single entity. This will be more costly and require more administration, but can provide a company with low downtime and a secure feeling. Two or more servers that work with each other are a cluster. The clustering of servers can be broken down into two types. Failover clusters, otherwise known as high availability clusters. These are designed so that a secondary server can take over in the case that the primary one fails with limited or no downtime. A failover cluster can reduce the chance of a single point of failure on a server regardless of what on that server hard disk, CPU memory, and so on. An example of a failover cluster would be the usage of two Microsoft domain controllers. When the first domain controller fails, the secondary domain controller should be ready to go at a moment's notice. There can be territory and quantity servers and beyond as well. It all depends on how many servers you think might fail concurrently. Another example would be the DNS server we talked about in the beginning of this chapter. If you wanted the DNS server to fail closed, then we should set up a secondary DNS server as a failover, one that will be ready to go at a moment's notice. Load balancing clusters. Load balancing clusters are multiple computers connected together for the purpose of sharing resources such as CPU, RAM, and hard disks. In this way, the cluster can share CPU power along with other resources and balance the CPU load among all the servers. Microsoft's cluster server is an example of this, although it can also act in failover mode, enabling for parallel high-performance computing. Several third-party vendors offer clustering software for operating systems and virtual operating systems as well. It is a common technique in web and FTP server farms, as well as in IRC servers, DNS servers, and NNTP servers. Data can also be replicated back and forth between servers, as it often is with database servers and web servers. This is actually a mixture of redundant data replication, and server clustering. However, it doesn't matter how many servers you install in a cluster if they are all local. They could all be affected by certain attacks or worse yet disasters. Enter the redundant site concept. Redundant sites, we have implemented redundant arrays of disks, redundant network adapters, redundant power, and even redundant servers. What is left? Devising a mirror of the entire network. That's right, a redundant site within the CIA triad. Redundant sites fall into the category of availability. In the case of a disaster, a redundant site can act as a safe haven for your data and users. Redundant sites are sort of a gray area between redundancy and a disaster recovery method. If you have one and need to use it, a disaster has probably occurred, but the better the redundant site, the less time the organization loses and the less it seems like a disaster and more like a failure that you have prepared for. Of course, this all depends on the type of redundant site your organization decides on. When it comes to types of redundant sites, I like to refer to the story of Goldilocks and the three bears, three bowls of porridge. One was too hot, one was too cold, one was just right. Most organizations opt for the warm redundant site as opposed to hot or cold. Let's discuss these three now. Hot site, a near duplicate of the original site of the organization, can be set up and running within minutes, maybe longer. Computers and phones are installed, ready to go. A simulated version of the server room stands ready, and the vast majority of the data is replicated on the site on a regular basis in the event that the original site is not accessible to users for whatever reason. Hot sites are used by companies that would face financial ruin in the case that a disaster makes their main site inaccessible for a few days or even a few hours. This is the only type of redundant site that can facilitate a full recovery. Warm site has computers, phones, servers, but they might require some configuration before users can start working on them. The warm site will have backups of data that might need to be restored. They will probably be several days old. This is chosen the most often by organizations because it has a good amount of configuration yet remains less expensive than a hot site. Cold site has tables, chairs, bathrooms, and possibly some technical setup, for example, basic phone, data, and electrical lines. Otherwise, a lot of configuration, computers, and data restoration is necessary before the site can be properly utilized. This type of site is used only if a company can handle the stress of being non-productive for a week or more. Redundant people. Well, not really a redundant people, but rather the redundancy of a person's role in its organization. A person doesn't work for a company forever. In fact, the average length of employment for IT management persons is less than 5 years. The level of attrition is in part made up of persons who have moved to other departments, leave for other jobs, take leave or absence, or retire. This leads to the important concept of succession planning, identifying internal people who understand the IT infrastructure and can take over in the event that an important decision maker departs. For example, IT directors, CIOs, CTOs, and other IT management persons. The concept trickled down to any IT person who works for the organization. That is where the concept of job rotation and separation of duties become very important. A high attrition rate requires cost training of employees. In smaller companies, the loss of one IT person could be a tantamount to a disaster if no one else understands or has access to the critical systems. That could truly be a disaster from a personal standpoint, but much more lethal in that is a disaster concerning actual data. Disaster recovery and planning. Regardless of how much you planned out redundancy and fault tolerance, when disaster strikes, it can be devastating. There are three things that you should be concerned with as a network security administrator when it comes to disasters: your data, your server room, and the site in general. You need to have a powerful backup plan for your data and a comprehensive disaster recovery plan as well. Data backup. Disaster recovery, or DR for short, is pretty simple in the case of data. If a disaster strikes, you better have a good data backup plan, one that fits your organization's needs and budgets. Your company might have a written policy as to what should be backed up. or what you might need to decide what is best. Data can be backed up to various media, other computers, SANs, NANs, devices, and to the cloud, but generally one of the local mediums is tape backup. There are several types of tape backup types you should be aware of. For example, most operating systems and third-party backup utilities support these types. Keep in mind that this list is not the end of all backup types, but it gives a basic idea of the main types of data backups used in the field. When performing any types of backups, a person must select what to back up. It could be a folder or an entire volume. For the sake of simplicity, we call these folders full backup. Back up all the contents of a folder. The full backup can be stored on one or more tapes. If more than one is used, the restore process would require starting with the oldest tape, moving through the tapes chronologically one by one. Full backups can use a lot of space, causing a backup operator to use a lot of backup tapes, which can be expensive. Full backups can also be time consuming if there's a lot of data. So often incremental and differential backups are used with full backups as part of a backup plan. Incremental backups only the contents of a folder that has changed since the last full backup or the last incremental backup. An incremental backup must be preceded by a full backup. Restoring the contents of a folder or volume would require a person to start with the full backup tape and then move on to each of the incremental backup tapes chronologically, ending with the last incremental backup tape. Incremental backups started in the time of floppy disks when storage space and backup speed were limited. Some operating systems and backup systems associate an archive bit or archive flag to any file that has been modified. This indicates to the backup program that it should be backed up during the next backup phase. If this is the case, the incremental backup resets the bit after the backup is complete. Differential backup backs up only the contents of a folder that has changed since the last full backup. A differential backup must be preceded by a full backup. To restore data, a person would start with the full backup tape and then move on to the differential tape. Differential backups do not reset the archive bit when backing up. This means that incremental backups will not see or know that a differential backup has occurred. Table 6.2 shows an example of a basic one-week backup schedule using the full and incremental backup types. A full backup is done on Monday and incremental backups are done Tuesday through Friday. In this schedule, 5 backup tapes are required, one for each day. Let's say that the backups are done at 6 p.m. daily. Often an organization might employ a 6th tape, which is a dummy tape. This tape is put into the tape drive every morning by the backup operator and is replaced with their proper daily tape at 5:30 p.m. when everyone has left the building. This prevents data theft during the day. The real tapes are kept locked up until needed. Tapes might be reused when the cycle is complete, or this organization might opt to archive certain tapes each week. For example, the full backup tapes and use new tapes every Monday. Another option is to run a full backup, which might be time consuming over the weekend, and archive that tape every Monday as long as no data loss is reported. This is a feasible option. Let's say that this backup procedure was used to back up a server. Now, let's say that the server crashed on Wednesday 9 p.m. and the hard drive data was lost. A backup operator arriving on the scene Thursday morning would need to review any logs available to find out when the server crashed. Then after an admin fixes the server, the backup operator would need to restore the data. This would require starting with the Monday full backup tape and continuing on to the Tuesday and Wednesday incremental backup tapes. So 3 tapes in total will be needed to complete the restore. Table 16.3 shows another possible backup schedule where a full backup is done on Monday and differential backups are done Wednesday and Friday. Let's say the backup operator needed to restore data on Monday morning due to a failure over the weekend. The backup operator would need 2 backup tapes, the previous Monday full backup and the Friday differential backup. Because the differential backup would have backed up everything since the last full backup, the Wednesday differential backup would not be necessary for recovery. Contrast this with the incremental backup schedule from table 16.2, where each tape will be needed for restoration in a differential backup scenario. The clear archive bit is not selected. So a differential backup will back up things that may have already been backed up by a previous differential backup. In an incremental backup scenario, the clear archive bit option selected and no items that are backed up by the incremental are not backed up by subsequent incremental. Some operating systems such as Windows Server manage full and incremental backups for the administrator. Windows Server 2008 or 2 and higher create incremental backups that behave as full backups. Any item can be recovered if need be, but the backup only occupies the space needed for an incremental backup. Now, the schedule we just showed in table 16 to 16.3 are basic backup methods, also known as backup rotation schemes. Organizations might also do something similar over a 2-week period. However, you should also be aware of a couple of other backup schemes using the field. These might use one or more of the backup types previously mentioned. 10 tape rotation. This method is simple and provides easy access to data that has been backed up. It can be accomplished during a 2-week backup period. Each tape is used once per day for 2 weeks. Then the entire set is recycled. Generally, this is similar to 1 week schedule shown previously. However, the second Monday might be a differential backup instead of a full backup, and the second Friday might be a full backup, which is archived. There are several options. You would need to run some backups and see which is the best for you given the amount of tapes required and time spent running the backups. Grandfather son. This backup rotation scheme is probably the most common backup method used. When attempting to use this scheme, 3 sets of backup tapes must be defined. Usually they are daily, weekly, and monthly, which correspond to son, father, and grandfather. Backups are rotated on a daily basis. Normally, the last one of the week will be graduated to father status. Weekly father backups are rotated on a weekly basis, with the last one of the month being graduated to grandfather status. Often monthly grandfather backups or a copy of them are archived upside Tower of Hanoi. This backup rotation scheme is based on the mathematics of the Tower of Hanoi puzzle. This also includes 3 backup sets. But they are rotated differently. Without getting into the mathematics behind it, the basic idea is the first tape is used every 2nd day, the second tape is used every 4th day, and the third tape is used every 8th day. Table 16.4 shows an example of this. Keep in mind that this can go further. A 4th tape can be used every 16th day and a 5th tape every 32nd day, and so on. Although it gets much more complex to remember what tapes to use to back up and which order to go by when restoring. The table shows an example with 3 tape sets represented as sets A, B, and C. To avoid the rewriting of data, start on the 4th day and cycle with tape C. This rotation scheme should be written out and perhaps calculated during the planning stage before it is implemented. Also, due to the complexity of the scheme, a restore sequence should be tested as well. Tapes should be stored in a cool, dry area away from sunlight, power lines, and other power sources. Most tape backup vendors have specific guidelines as to the temperature and humidity ranges for storage, along with other storage guidelines. Tape backup methods and tape integrity should always be tested by restoring all or part of a backup. It's also possible to archive data to a third party. This could be for backup purposes or for complete file replication. Several companies offer this type of service, and you can usually select to archive data over the internet or by courier. So far, we have been discussing how to back up groups of files. However, you can also back up entire systems or architectural instances. For instance, a snapshot backup backs up an entire application driver system. It is also known as an image backup, especially when referring to back up an entire operating system. Most of the time, this is done when a new system is installed and configured, but it can also be done when major changes are made to a system. Some organizations even back up images of all systems every month, even every week. This requires a lot of resources and a decent IT budget, so it must be planned accordingly. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.